Wait a second, it's not okay. Started. Fine. Okay. So we have studied previously. We have studied two types of flow meters. Flow meters are one which are measuring the discharge. Which one were those? Venturimeter and orifice meter. Venturimeter and orifice meter. Okay. So today we're going to discuss another one type of flow meter which is known as V notch. Sorry, you can say notches and Weirs. Notches and Weirs. So a notch is a device which is used for measuring the rate of flow. Notch is a device which is used to measure the rate of flow of a fluid which is flowing through a small channel or a tank. Which is flowing through a small channel or a tank. Imagine that there is a tank and there is an open channel to this. Okay, open channel. There's a rectangular channel to this, and the water is flowing through this. Okay, there's a difference between a channel and a pipe. Okay, channel and a pipe. Okay, a pipe or conduit, we say conduit, or we can say a penstock. Okay, these all are like pipelines only, where through which water or liquid flows. Okay, so it is used to measure the rate of flow of a liquid flowing through a small channel or a tank. Small channel or a tank. Okay, it may be defined as an opening in the side of a tank or a small channel in such a way that the liquid surface in the tank or channel is below the top edge of the opening. So these are like this. So if this is the tank, okay, this is the tank. In this there will be an opening here. Okay, so the water is filled. When it fills this, it will be the fluid will be coming out of this. Okay, fluid will be coming out of this. This notch may be of different shape. It may be of a triangular shape. It may be of a rectangular shape. It may be of a trapezoidal shape, and etc. Okay, so this is just to measure the flow rate of a fluid, and it may be an opening in the side of a tank. It may be opening here in the side of a tank, or a small channel. Okay, if there is a tank and if there is something and there is a small channel like this through which the fluid is flowing. Okay, and the top of this there is this is called as a notch. Okay, through which the water is following like this. We have this in our lab, in fluid mechanics lab, where you can measure the rate of flow and in the notches. Okay, fine. So these notches are placed in a we can say a small scale. If you want to measure the small scale of a flow rate through a pipe or a channel or a tank, we can use a notch. But what is meant by weirs? Weirs are same type of notches, but they are made from concrete or masonry structure. They are made from concrete or masonry structure, which are placed in an open channel over which the flow occurs. If there is an open channel, okay, closed channel means if there is a duct. Okay, if there is a duct, okay, duct means what? It will be square duct. Okay, a pipe means it will be circular. A duct through which it may be open means what? From the top we can see, from the top it is open. It is open to the atmosphere. If it is closed one, then it will be completely closed one. Okay, through which the fluid is flowing. But here it is a duct which is open channel over which the flow occurs. It is generally in the form of a vertical wall. We can place it in a form of a vertical wall with a sharp edge at the top, running all the way across the open channel. The notch is of a small size, while the weir is of a big size. I have told you that notch and weir are same, but notch is made up of a metal plate and it is very small compared to the weir. But the weirs are mainly because of concrete or masonry structure. Okay, you might have observed this near the dams. Near the dams, there will be some kind of channels beside it. You might have observed that. It will be in the shape of like this. Okay, so through which the water will be flowing. Okay, so here these are the weirs which will measure the flow rate of water which is flowing through the dam or whatever structure we are going to create. Okay, if I want to measure how much amount of water is flowing, so what we do, and it is a huge space or reservoir, then we can use the weir. Okay, so what happens is whenever this tank, if I imagine that if this is a masonry structure like this, okay, this is a tank wall. Okay, and to this I'm connecting a notch. So the trapezoidal notch. Okay, so what will happen? The water will come out of this like this. If you are seeing from the front view, it is falling like this towards us. Okay, and when it falls, we want to know the height. This side is known as nappe and this side is known as crest. Okay, so water touching the below part of the weir or notch is known as crest, or the water on the upper side of the this one is called as nappe or vein. Okay, right. The notch is generally made up of a metallic plate. So I have told you that notches are made up of metallic plate and the weir is made up of a concrete or masonry structure. Okay, then see here, this type of, these are only used for measuring the rate of flow in a channel, open channel. Okay, or not through pipes. Okay, there might be rectangular duct or rectangular channels. You might have seen this channels in or in near the villages and all. Okay, where they are using this to get the this one. What we say?
Excuse me, sir.
Yeah.
Sir, some students are waiting, sir.
Okay. Fair. Fine. Fine. So the notch is generally made up of a metallic plate, which we have in our college. We have a notch at our college. That is, we have a square one, rectangular one, and we have a triangle pattern. Okay, right angle triangle. While weir is made up of a concrete or masonry structure. So this nappe is nothing but the sheet of water flowing through a notch or over a weir is called as nappe. And the crest is the bottom edge of the notch or a top of a weir over which the water flows is known as the still or crest. So when the water will be flowing from this duct, okay, it will be like this. Imagine that it is like this. So the water will be coming through this channel. This is complete channel. Okay, this is complete channel, and we are placing a duct in that this notch. The water will be coming from this. This part is known as nappe, and this part is known as crest. Okay, nape or nappe, or we can say vein. Okay, same way we can see here. Then the next derivation which we are going to do will be I'll be showing how it works. Okay, so we are having both notch and weir, both are same. Okay, and notch is made up of a metallic plate, while the weir is made up of a concrete or masonry structure. The weirs are mainly used in dams and all. Okay, to measure the rate of flow and anywhere where there is a large reservoir and we want water from there. Okay, some people will be constructing some concrete structures where they want to measure the flow rate and they are using weir. Okay, now. So we'll be going with first derivation, that is discharge over a rectangular notch. So rectangular notch will be like this. It will be like this. Rectangular notch, this one. Okay. So we'll be deriving the equation through which we can measure the discharge over a rectangular notch or a weir. Notch or weir, because notch and weir are both are same, right? So if we can use this expression in notches, or also we can use this expression in weir. Okay. So the expression for discharge over a rectangular notch or weir is the same. Both are using the same expression. As the notch and weir are same, the only difference is that these are made up of metals. Notches are made up of metals and these are made up of masonry structure. Okay. Done. So this is a notch. So as I have told you, see here. This is a notch, rectangular notch. So if you are seeing it from the side view, but from the front view, it looks like this. Okay, this is a rectangular notch through which the water is flowing. So this part is there, this part. Whatever this part is there, that is this part. Whatever this part is there, that is this one. Okay, and open, it is open to the atmosphere like this. So the water will be flowing towards us. Okay, it is flowing towards us, right? So then it means that from the side view, the water is flowing in this direction, like this. Okay, so the top part is called as nape or nappe, and the below part is called as crest or sill. Crest or sill. So I want to know the depth of water which is falling from the rectangular notch, that is h. H is the thickness of water which is flowing from the notch. Okay. Now, for an example, if I reduce the flow rate, what will happen to this H? अगर समझो ये tank है अभी, there is a tank behind this, and I've connected this open channel to this. Okay, and water I have filled it using the valve. Okay, I'm filling the water is filling this, and it is falling from here. So I can measure the rate of flow from here. Okay. Now my question is that if I reduce this, if I partially open it, now it is fully open. Okay, if I partially open it, what will happen to H? Will it reduce or increase? Capital H?
Reduce.
Reduce, because the amount of flow rate of water will be reduced, right? So अभी क्या होगा, जब तक ये जो पानी है ना यहाँ तक नहीं भरता, यहाँ तक भर गया रहता है अभी पानी, but due to overflow it will start falling from here. Due to the overflow it will start falling from here. So excess water if we get, now whenever you are filling water in your tank, okay, sometimes what will happen, the extra amount of water will be overflowed, right? Sometimes you miss the timing and sometimes you don't switch off the pump. Okay, so क्या होता है कि extra पानी जो रहता है गिर जाता है tank से. So if you keep a bucket below that tank, okay, for an example, बता रहा हूँ ऐसे मत करो क्योंकि you should not waste water. Okay, if you keep a bucket and you measure its time, okay, so what it will show, it is taking so much time to fill this bucket. So you can just compare it with the tank. Okay, then you can measure the rate of flow of water which is flowing in the tank. Okay, same way, whenever the water is filling, it is filling this whole part, and from this we are measuring the amount of water from the crust to the nappe. So that is H. If I reduce the flow rate, this H will also reduce. Okay, that is falling in the shape of a rectangle. You can see here. That is falling in the shape of a rectangle. Now you can see that what is happening is, this is a cross section at L, cross section at crust. This is L. Okay, so if you are seeing it from the side view, if you are seeing it from the side view of this, यहाँ पे अगर देखोगे, so this is the cross section at the crest, मतलब यहाँ से. So perpendicular to the this laptop or perpendicular to the plane, it will be having length L. Okay, like this it is. Okay, this is the length L. This is length L. Okay, and so if we consider a section or a fluid element in this water, in this H, if I consider a fluid element from the nappe at distance H, okay, and the fluid element will be having a distance of DH, so we can find the expression. Okay, so the same way, same thing, same rectangular notch is there for a rectangular Weir. It is also having crust, it is also having nappe, but the only difference is that it is made up of a metal, it is made up of a cement or masonry structure. Okay, so we will, while deriving the expression, I will tell you what is H, small h and DH, but the length will be the L. मतलब जितना पानी गिर रहा है उस पैसेज से कितना लेंथ का पानी गिर रहा है, so this length is known as L. Okay,
sir, the bending that we called as notch, no, means where the bending is taking place of water.
This is notch completely. This is notch. Whatever is this is notch, rectangular notch. Okay, but at this point where it is bending now, that is called as crest. This is called as crest. This is called as nappe. This is the part where the water is in contact with the air, and this is the part which is there, still there is water. But at this point where the notch ends, that is called as crest, and this is called as nappe, not notch. Okay. Anything else? Fine. So we are considering a rectangular notch or weir provided in a channel carrying water as shown. Okay. So water is coming from here. Okay, filling the crest, filling the full notch, and it is falling because of it is overfilled. Okay, that it is happening there. The overflow which is happening. Okay. Now let H equal to head of water over the crest. So I have told you. So H is the head of water. Head of means height of water from the crust. From the crust. Remember this, huh? Remember the terms. Let capital H equal to head of water from the crust or over the crust. Over the crust. This is the crust part. जिस पॉइंट पे टच हो रहा है ना पानी उसको crust बोलेंगे. यहाँ से गिर रहा है ना. This is the point where it is deflecting. Okay. If I reduce the flow rate, it will reduce. Okay. If I increase the flow rate, it will increase. Right. So this is the point where it is touching and it is falling. Base part of the notch. Okay. Now, consider a rectangular notch or weir provided in a channel. Let H be the head of water over the crust. Length of the notch or weir is L. Length of the notch. मतलब मैंने बोला था ना, if you see actually the notch will look like this. I have drawn it again and again. So it looks quite lengthier, but this is the length. This is the length, and height of water will be this H. Height of water will be H. It may be here also because water, if flow rate is more, it will increase. When the flow rate increases, H also increases. But from the base of crust, from the crust, this is the crust. And this is the water through which it is flowing. अगर मैं क्या करूँगा अभी reduce करते जाऊँगा discharge समझो. If I go on reducing the discharge, what will happen? This will also go on reducing. Okay, H will also go on reducing, capital H. But length will remain same because we cannot change the shape of the notch. Okay. For finding the discharge of water flowing over the weir notch, considering an elementary horizontal strip of water of thickness dh and length L at a depth h from the free surface of water. So that's what I told you, that this h, this part is this one, this part complete. Okay, this is open to the atmosphere, which is known as free surface. It is the free surface, right? Free surface means if water is open to the atmosphere, it is the free surface. The surface of water which is open to the atmosphere is free surface, right? Now, so this whatever is there now, this is nappe, and this is point where it is crust. This is crust, and water का thick length कितना होगा fall होने का notch से L, length L it is falling for a length L. Okay, now what is telling that consider an elementary horizontal strip of water. So I cannot take this whole area of water which is falling and measure its discharge. I want to consider only a strip of water from that whole water, from that whole H, and I want to consider a strip of water thickness, elementary thickness like this. So that is having a thickness of dh from the height of H from the nap. Okay, from the nap. Okay, that is shown in the figure. Okay, so see here. So this is the water which is falling from the notch. So I'm considering an elemental area in that water, in that the water which is flowing down. Okay, from the height H, from the free surface of water H. Okay, I'm considering it, and it is having an elemental thickness of dh. Okay, at length L from the depth H from the free surface of water, and it is having an elemental thickness of dh. Next, what will be the area of the strip now? Area of the strip. Area is length into breadth. So this is the length and this is the thickness. That is length into dh. Now, theoretical velocity of water flowing through the strip is square root of 2gh. Theoretical velocity of water which is flowing through the strip. We want the velocity to which is there in the flowing through that strip is, we are taking it as square root of 2gh. Now, the discharge dq through the strip. Now we are considering the elemental strip of that water which is flowing. Okay, which is having a thickness of dh. By taking the discharge which is through that elemental area horizontal strip of water, elementary horizontal strip of water, we are going to measure the dq, and by integrating it we have to measure the we are going to measure the whole discharge from the rectangular notch. This type of derivation you will be getting. Okay, like we are taking, see for an example, अभी एक पाइप में पानी फ्लो हो रहा है. Okay. So it is having a diameter of, imagine that it is having a diameter of 100 centimeter. Okay, or let it be, we'll take 1 meter. Why to make you confused? Okay, so it is having a pipe of 1 meter, diameter 1 meter है, बहुत बड़ा हो गया. ठीक है, 1 meter का diameter. Now I want to measure the properties which is flowing through this pipe. Okay, do I have to check everywhere in the pipe, in that whole 1 meter diameter of pipe? I have to check everywhere. लेंथ भी 1 मीटर ले लो, 1 into 1 मीटर का लेंथ ऑफ पाइप है, एक लेंथ 1 मीटर है, डायमीटर भी 1 मीटर है. So do I have to check everywhere in that pipe what, how much amount of fluid is flowing and all that?
No, sir.
No.
Sir.
So what I'll do, I'll consider a section in that pipe. I'll consider section in that pipe, and all the parameters are considered here itself. All the parameters are considered here itself, and I will integrate this, whatever value I get, and I will check it for the whole pipe. So the values will be nearly equal. Okay, so the same thing we are doing. We are not considering the whole water which is flowing through this rectangular notch. I'm considering that water which is flowing through the notch, and in that I'm considered a strip of water which is having a thickness of dh, and from the edge height it is this much. Okay. Now, if I want to calculate the discharge, you have to go with the dq. Dq is the discharge through that strip, not for the whole water which is falling. So dq is given by CD into area of the strip into theoretical velocity. We know what is q. Q is area into velocity. Okay, q is area into velocity. So we want it to be a actual discharge. That's why he has taken CD into area of strip into theoretical velocity. Area of strip into theoretical velocity. Okay, so what is q? CD equal to q actual by q theoretical. Okay, so I want q actual. So dq, I want q actual, right? So q actual will be CD into q theoretical. So CD is there, q theoretical is area of strip into theoretical velocity. Okay, don't get confused with the definition. CD is what, q is what, q actual, CD is what, sorry, write it again. CD is what, q actual by q theoretical. Okay, now I want the value of q actual. It will be what, CD into qth. But CD into qth means area of the strip into theoretical velocity vth, because there is theoretical discharge. So I want the discharge which is, I want the velocity to be theoretical velocity. That's why it is theoretical, the area of strip into theoretical velocity. Okay, next. Next, what we have to do? We have to write the equation. CD into L. L into DH is the area of the strip, which we have seen in the previous slide. Area of the strip is L into DH. So CD into L into DH into square root of 2GH. Square root of 2GH. CD into L into DH into square root of 2GH is your equation 1. Now it figure equation 1. Now what we have to do? CD is the coefficient of discharge, you know that. So the total discharge Q for the whole notch or weir is determining by integrating equation 1. We have to integrate equation 1 by within the limits of 0 to h. Why we have to integrate within the limits of 0 to h? Can anyone tell me? Why we have to calculate the discharge, the whole discharge, from 0 to h, within the limit of 0 to h?
Sir, h is the maximum thickness of flowing water.
Correct. Capital H is the maximum thickness of flow water, and this is 0. So I have, this is, अगर ये हमारा thickness of water है which is flowing from the notch, and if I consider a strip of thickness from that, this is dq, but I want the whole flow rate na. So that whole flow rate I have to integrate using the from 0 to this capital H. Okay, good. So I have to integrate the expression now. So Q equal to integration of 0 to H into CD into L square root of 2GH into DH. Can anyone just try it and tell me what is the answer for discharge? CD will remain constant. Okay. L will also remain constant because once the notch is done, you cannot change the length. Length won't change. Okay. Square root of 2G will remain constant because square root is 2 is constant, G is constant. You take everything out. CD, L, square root of 2G you take outside. So what will be there? Remaining will be integration of 0 to H into TH. See, CD is constant, length is constant. Length, why it is constant? Because अगर मैंने एक बार notch बना दिया तो ये length same रह जाएगा ना. I cannot compress it, I cannot extend it, right? So the length will remain same. So that is a constant. Next, square root of 2G will be remain constant. So it is coming out. Integration of 0 to H. H raised to half Q. It is H raised to square root na. Because square root पूरे सबके लिए है ना square root of 2GH. So but square root of 2G बाहर आया तो H raised to square root of H रहेगा. So square root of H we can write as 1 by 2. H raised to 1 by 2. Do you agree or no, everyone? Is this expression right or wrong?
Right, sir.
Right. Okay. So H raised to 1 by 2. Now we integrate this. You have everything now. Now what we have to do? CD into L. CD into L into square root of 2G. Okay. Now I have to integrate the expression. So H, it is like x raised to n. So integration of x raised to n is x raised to n plus 1 divided by n plus 1. Right or wrong? X raised to n plus 1 divided by n plus 1. So what it will be? H raised to 1 by 2 plus 1 divided by 1 by 2 plus 1. Okay. Raised to 0 to H. Okay. So what will be there? Am I getting the correct answer? So H raised to 2 by 3. So sorry, 3 by 2 divided by 3 by 2. Correct? Everyone got the same answer? CD into L square root of 2G. Integrate H raised to 1 by 2. It will be what? H raised to 3 by 2 divided by 3 by 2. Correct? Hai?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So H raised to 1 by 2 plus 1 divided by 1 by 2 plus 1. So it will be CD equal to L square root of 2G H raised to 3 by 2 3 by 2. Now any one of you give me the final expression for this. Another expression is there, final expression. Can anyone tell me the final expression?
Sir, applying limits.
Applying limits. Apply and tell me. Tell me the final answer. CD into L into square root of 2J will remain same. There is no change in that. What will change here? What will change? You have to put this H here. H raised to 3 by 2 by 3 by 2 minus. You can put 0 here, but there is no use. So what will happen? What will the final expression? Can anyone tell me? Final expression, guys, fast. What will be the final expression? Any one of you?
Two by three into CD into L
Hmm.
root of 2G H raised to 3 by 2.
Very good. So 2 by 3 CD into L into square root of 2G H raised to 3 by 2. Fine. This is the answer. Okay, any doubts in the derivation? First, you understand what is a rectangular notch or weir. You just understand that notch is made up of a metallic structure and weir is made up of masonry structure. Both are same. Both are having the same discharge. Similarity are same. But the only thing is that these are used in practical applications, the weirs, and the notches are used in wherever there is small kind of small channel or a less less diameter of less length of channels. Okay, but here in weirs we are using your dams and practical applications wherever it is required, and we are building it using the cement. Okay, and so whatever we have seen till now, it is for a rectangular notch because it is in the shape of a rectangular like this. So whatever water is flowing here is the same water which is flowing towards us. Why I'm telling towards us? Because I'm seeing it in front of me now. So it is, I'm seeing it on the screen. So it is flowing towards me. Okay. So it is falling. If you put your hand down below this water, you can have that water. Okay. So like this. Fine. Understood the derivation?
Yes, sir.
Okay. Now we'll go to the next derivation that we'll go to the problem, then we'll go for triangular notch derivation. We'll go for a simple problem. Okay. You everyone note down this everyone note down this formula. Q equal to 2 by 3 CD into L into square root of 2G H raised to 3 by 2.
Yes, sir.
Note it down. Okay. So you read the question and try to solve it. Determine the height of a rectangular weir, of length 6 meter to be built across a rectangular channel. Okay, as I've told you, we are using a rectangular channel. Okay, there is a rectangular channel here. Okay. Now there is a height. Determine the height of a rectangular weir of length 6 meter to be built across a rectangular channel. The maximum depth of water on the upstream side of the weir is 1.8 meter and discharge is 2000 liters. Take CD equal to 0.6. Determine the height of a rectangular weir. Which height you have to measure? Which height you have to find out? Determine the height of a rectangular weir. So if you consider, I have a diagram, I'll show you. So which height you have to gonna see? See, the question is like, determine the height of a rectangular weir of length 6 meter to be built. Length kitna hai? It is perpendicular to this plane na? So it will be like this. On that side it will be length L equal to 6 meter likho. Baad mein. Across a rectangular channel, the maximum depth of water on the upstream side. Which is the maximum depth of water? H1, H2 or H?
Yes, sir.
The maximum depth of water on the upstream side. This is the upstream side. Now tell me which is 1.8 meter, H1, H2 or H?
H1.
H1, because he is telling maximum depth of water. So maximum depth of water is from where? From the below. I have told you this part is also filled. अभी ये ओवरफ्लो इससे भर के ऊपर जा रहा करके पानी बाहर गिर रहा ना, नहीं तो ये काम गिरता है कि हवा में है क्या अभी पानी नहीं ना. So the water is also there here in this part. Okay, because of overfilling, what is happening? It is overflowing from the tank or from the channel. Understood the point? So the पानी यहाँ तक पूरा भरा हुआ है, तो क्या हो रहा है, जब ओवरफ्लो हो जाएगा ना तो पानी यहाँ से गिर जाएगा. तो ये कितना गिर रहा है ना, कितने हाइट पे गिर रहा है ना, दैट इज हाइट इज नोन एज एच, कैपिटल एच। ठीक है, अभी हम लोगों ने पता लगाया कि H2 is the H1 is the maximum height 1.8 meter and it discharges 2000 liters of water, that is Q. He has given Q. To take CD equal to 0.6, CD you have to find out. Okay, now I'll write what is the expression for that discharge? Q equal to 2 by 3 CD L into square root of 2G H raised to 3 by 2. Is this expression correct?
Yes, sir.
Okay, now we have CD value, coefficient of discharge, we have length 6 meter, square root of 2G, square root of 2 into 9.81. So now what we have to calculate is, we have to, now he has told something to calculate, that is determine the height of the rectangular weir. So which is the height of the rectangular weir? Can anyone tell me which height is this? H or H2? H1 तो पता चल गया, H1 1.8 है, H1 is 1.8. Determine the height of a rectangular weir. Which is that, H2 or H?
H2.
H2. H2. Very good. Why? Because if this is the length, उस side length है, not this side. You are seeing it from the side view. So on the perpendicular to the plane, on that side there is length. Okay, I have told you what is length. So what he is asking is, he is telling that to measure, if this is the rectangular weir, okay, and this is the length. इसको ही बना रहा हूं मैं, इसको ही बना रहा हूं. Okay, now the H, this is the H total. Okay, so the maximum depth of water is how much? Maximum depth of water is H1, ये वाला H1 1.8. Now he is telling you to calculate H2, height of the rectangular weir, height of the rectangular weir. Okay, now the question is understood, I hope. Okay, we have the formula. Now what I have to calculate? I have to calculate the value of H. Okay, if I calculate the value of H, I can subtract it with H1. H1 I can subtract or differentiate, because H will be smaller compared to H1. So I have to subtract H1 minus H to calculate H2. Okay, so can you just then how you're going to calculate the value of H now, capital H? How are you going to calculate the value? That discharge formula. Okay, you start finding the value of H now. So I'll show you that length of the weir is 6 meter, capital L. Depth of water is H1 equal to 1.8 meter. Discharge is 2000 liters per second, which is nothing but 2 meter cube per second. As this 2000 is divided by 1000, we can convert it into meter cube per second. And the coefficient of discharge is 0.6. And let H be the height of water above the crest of weir, above the crest of the weir, H. Above the crest. This is the above the crest का जो पानी आएगा ना, that is H. I have told you. This is crest. Above the crest, whatever is there, that is capital H. And H2 is the height of the weir. Height of the weir. Now you calculate the value of H, then you subtract it with H1, then you will get the height of weir. Calculate it. Equation is there. Values, CD is 0.6, length is 6 meter, Q is 2 meter cube per second. Shall I solve it? 2 equal to 2 by 3 into 0.6 into 6 into square root of 2 into 9.81 into H raised to 3 by 2. Anyone got the answer? It's an easy one.
Sir, 0.33.
h raised to 3 by 2, not h cube by 2. Anyone got the answer? Now at least try to solve it fast, everyone.
Calculating.
Yeah. Yeah.
Sir, 0.33.
0.33. Okay, very good. So I got 0.328, that is correct. 0.33 meter. Now you calculate h2. You got h. You remember h, huh? 0.33. Okay, I'll tell you how to get h2. Okay. Fine. You calculated the value of h. That is h equal to 0.33. What is h1? 1.8.
H1 minus
h1 minus h is your h2.
1.472, sir.
1.472. Very good. The answer is correct. 1.472. 1.472 meter. Okay. Understood how to solve the problem. And the next problem, you have to do it. And it's a very easy problem. Okay. I'll read the question and you have to solve it. Okay. The head of water over a rectangular notch is, you understood the problem or no, the previous one? You got
Yes,
this?
sir, understood.
You got this much answer? I'll go for the next problem now. So the head of water over a rectangular notch is 900 mm. Head of water there over a rectangular notch is 900 mm. The discharge is 300 liters per second. Find the length of the notch. It's a very easy problem. You don't have to do any extra work. You have to use the same formula of the discharge and calculate the length. Calculate. You only calculate and tell me the answer first. You know the formula? Q equal to 2 by 3 into L into square root of 2G into CD. Okay. H raised to 3 by 2. क्या दिया है? Square root of 2G है. We have the value of CD 0.62. H is given 900 mm. Convert it into meter. Substitute. Q is given 300 liters per second. Convert it into meter cube per second. Substitute. Then find the value of length L in terms of meter. Then you convert that in terms of mm. It's a very easy problem. Solve it as soon as possible.
.39.
0.19 meters. Very good. So the answer is 0.19 meter, or we can write as 192 कुछ आता है ना, 0.192 के आगे कुछ आएगा, so it is 192 mm. Okay, correct?
0.1919 meter sir.
So 0.1919 ಅಂದ್ರೆ ಹೆಂಗ್ ಮಾಡ್ಬೋದು ನೀವು? 0.1919 ಅಂದ್ರೆ, so this is 9, it is more than 5, so just change this to round
Yes,
off
sir.
it to 0.92, the next
Yes, sir.
number.
Yes, sir.
Okay, this is your answer. In terms of meter, convert it into mm, it will be 192. Okay, done. Easy problem.
Yes, sir.
Any doubts?
No.
Okay. Now we shall go for another derivation, that is discharge over a triangular notch or a weir. Discharge over a triangular notch or a weir. Can you give me just 2 minutes? Just give me 2 minutes. Okay. Fine. Am I audible? Hope I'm audible to everyone. So we will go with the next derivation. Discharge over a triangular notch or a weir. Okay. This is we have previously done a discharge over a rectangular notch because it was in the shape of a rectangle. Okay, which was in the shape of a rectangle. Hope I'm audible to everyone. Am I audible?
Yes, sir.
Yes, sir.
So thank you. So first we have done it based on the rectangular notch. Okay. Now we'll be going for a triangular notch. So triangular notch, obviously it will look like this in the shape of a triangle. It will be shape of a triangle. And whatever angle is this now, this will be 45 degree or 60 degree. Okay. So these are the triangular notch or a weir. Triangular notch or a weir. So we are going to derive an expression for this now. So we, as I have told you, that the discharge formula will be same for both notches and weirs. Here also it will be same for both triangular notch and triangular weir. So this is the notch. So see. Now you might have understood. So this is abhi dekho, agar main isko pura draw karunga na, it will be like this. Okay. So what happens is there is a space which is provided in the shape of a triangle. The water, if it will behind this part, there will be a channel. Okay, channel where the water is flowing. Okay, if it overflows, at this point it will overflow. It will start filling, and at this point start filling, and it will start coming out and overfilling the notch. Okay, so water will it will be falling towards me. You can see. पानी गिर रहा है, मेरी तरफ से गिर रहा है, ठीक है? So this is the discharge of triangular notch. As I have told you on rectangular notch, if I go on reducing the discharge, the water will, this height will go on reducing, this h will go on reducing. Okay, can anyone tell me where is crust and where is nappe? This is nappe, this is crust. Okay, same way in the previous part where we have taken an elemental area, in this triangle also we are going to take an elemental area, that is dh. We are going to take an elemental area, that is dh. Okay, from the height h of the free surface of water. This is free surface because it is open to atmosphere. So this is the free surface of water, so which is open to from that height h, small h. This is the elemental area dh, and the height from the nappe to the crust is capital H. This we have already seen in the rectangular notch. Only difference is that it is a triangular notch. So it is at some angle. This is something theta. This angle is theta. Okay. This angle is theta. So they have shown here. The clear and good diagram. Okay. Then this AB is our elemental strip. It is having a thickness of dh, and from the height h, we have taken this elemental area. The capital H is the height from the nappe to the crest. Okay. And now this whatever the half part of this diagram B part, figure B, is the half part of this whole. The half part of this one. Okay, half part. So this will be what? Theta by 2. So we have taken O, A and C till the elemental area. O, A and C. This one. So this is the half part. So theta ka half kya hoga? Theta by 2. And this H will be, and this height will be what? From this to this, it will be capital H minus small h. Capital H minus small h. So we have taken this from this part. Okay. This will be symmetrical itself. At this end also it will be same. At this end also it will be same. So here it is theta by 2. Here O, A and C. And this height will be H minus small h. Okay. Now we have to derive an expression for the discharge. So let theta will be the angle of notch, angle of the notch, triangular notch. Capital H equal to head of water above V notch. Capital H will be head of water. So अभी देखो, अभी क्या हो रहा है? If this is a notch, complete notch, and water is filling till this point, it has filled. So whatever water, if I overflow the water, if I increase the discharge of the water into that channel, okay, if whatever tap I am having, if I increase the flow rate or whatever this one, what valve I am having, and what I'll do, I'll increase the discharge of water. So what will happen? The water will rise, starting rising into this notch. Okay, so it has some space to come out. Now it will start coming out from this. Okay, that is the head. H is the head above the notch, V notch. At this point, whatever head is there above the crest or above the V notch is known as H. Okay. Consider a horizontal strip of thickness dh at a depth h from the free surface of water as shown in the figure. Like in the previous derivation, we are considering a small thickness of dh at a depth of h from the free surface of water as shown in the figure. From figure B, this is the figure B which I have drawn. So what we get from the figure B, what we can observe is that tan theta by 2 equal to AC by OC equal to AC divided by H minus H. Okay, tan theta equal to theta by 2 is what? What is tan theta? If this is theta by 2, what is tan theta? Perpendicular by hypotenuse. What is tan theta? Opposite by adjacent, right? Opposite by adjacent. Which is opposite? This is opposite by adjacent. AC divided by H minus AC divided by OC is our tan theta. So that is why I have taken this. I'll tell you. Okay, while deriving, when we get at the end, you will have a clear idea why we have taken. Okay. From figure B, it is tan theta by 2, AC by OC, AC by OC equal to AC is how much? We don't know, but we know OC, that is H minus H. Now, AC equal to what? H minus H into tan theta by 2. So AC, यहाँ पे रखो, H minus H into tan theta by 2. Now, what is the width of the strip? That is equal to AB. From, if you see, width of the strip. So this is the width of the strip AB. This is the width of the strip AB. So what it will be? AB. So that will be 2 times of AC. So if I consider this elemental area to be like this, consider this elemental area to be like this. This is whole AB. This is whole width of the strip, that is AB. Okay. Now it is half of AC, 2 times of AC, because I have told you that both are symmetrical. Right. So both are symmetrical means if this is AB, width of the strip, it will be equal to 2 times of AC. AC is from here to here, BC. Okay. So 2 times of AC equal to AB. The width of the strip is 2 times of AC equal to 2 times of H minus H into tan theta by 2, because AC is nothing but H minus H pi into tan theta by 2. So AB equal to 2 AC, 2 into H minus H tan theta by 2. Now what will be the area of this strip? That will be AB into the DH. Okay, AB into DH. So that will be 2 into H minus H into tan theta divided by 2 into DH. Okay, now the theoretical velocity of water through the strip is square root of 2gh. Now what will be the equation for discharge? Anyone? dq equal to, same way, the previous in the previous derivation we have got that expression. What was dq? dq equal to what? CD into area of the strip into theoretical velocity. dq equal to CD into area of the strip into velocity, theoretical velocity. Now substitute the values and tell me the answer. What will be the CD value? We have to see that the constant. Area of the strip is given as 2 into H minus H. 2 into H minus H tan theta by 2 into DH. 2 into H minus H tan theta by 2 into DH into what is theoretical velocity? Wait. Into square root of 2gh. Okay. 2 CD into 2 H minus H into tan theta by 2 into DH into square root of 2gh. Now how can you get the expression for this? Okay. This is the formula which we have got. CD into 2 into H minus H tan theta by 2 into DH into square root of 2gh. 2 into CD, 2 times of CD into H minus H tan theta by 2 into square root of 2gh into DH. Now we got the expression. Now do we have got dq. Now what I have to do to get q? To get q, what I have to do?
Integrate.
Integrate in the limit of what? Integrate within the limit of 0 to h. Integrate, the total discharge is given by integration of q equal to integration of this. You have to integrate this one. Okay. Now, what all is constant over here? 2 is constant, CD is constant, tan theta by 2 is constant, square root of 2g is constant. Okay, which is not constant? H minus H, H raised to 1 by 2 into DH. Here. 2 CD tan theta by 2 square root of 2g, square root of 2g, 0 to h, 0 to h, h minus h, which is this is h minus h, integration of 0 to h to h minus h into, when I take the square root out, it will be h raised to 1 by 2 into dh. The only difference between that and this is, the previous one and this is, here it was h raised to half only, but here it is h minus h into h raised to 1 by 2 dh. Okay, fine. Calculate. Next, what you're going to do? Integrate this. How you going to integrate? So we have to integrate with respect to dh now. So multiply this h raised to half here and rest is to half here. So it will be h into h raised to half minus h raised to what? 3 by 2 into dh. Expression will be like this. 2 into cd tan theta by 2 square root of 2g integration of 0 to h raised to 1 by 2 minus h raised to 3 by 2 dh. Correct? Correct or no?
Yes, sir.
Okay. Now you integrate and tell me the final expression if you can. Now if I integrate it, what will happen? Anyone? I'm integrating it with respect to dh. Integration of with respect to dh. So h into h raised to 3 by 2 divided by 3 by 2 minus h raised to 5 by 2 divided by 5 by 2. Is this correct or not? I am only integrating this part because this is everything is constant. If integration of this whole term, with respect to dh. Okay, so h remains as it is. H raised to 3 by 2 by 3 by 2 minus h raised to 5 by 2 by 5 by 2. Is this right or wrong? Check whether you're getting the same thing. Okay. So 2 cd tan theta by 2 square root of 2g. So when I integrate it, h raised to 3 by 2 by 3 by 2 minus h raised to 5 by 2 by 5 by 2. Because it will be h raised to 3 by 2 plus 1 divided by 3 by 2 plus 1. This will be h raised to 5 by 2 divided by h 5 by 2. Agreed? Is this correct or no?
Yes, sir. Correct, sir.
Now what you are going to do? Substitute the value of h here inside this. So what it will be? H into capital H raised to 3 by 2. Right? I'm taking the limits inside. So h raised to 5 by 2, capital H raised to 5 by 2 divided by 5 by 2. Correct. So the expression will be like this. See, I have substituted the value of h here in small h raised to 3 by 2. Substituted here h raised to 5 by 2 because I am putting the limits inside. Okay, so it will be 2 by 3, 2 by 3, and this will be 2 by 5. Now is this correct? Now what will be the next expression? You just tell me. You don't see this. This is all constant. You can understand this. But what is this now? New term. Four by 15 into h raised to 5 by 2. Correct? So 2 by 3 h raised to 5 by 2 minus 2 by 5 h raised to 5 by 2 common. So when you do the LCM, you will be getting 4 by 15 into h raised to 5 by 2. Now what will be the final expression? 8 by 15 into CD into tan theta by 2 square root of 2g h raised to 5 by 2 will be your final expression. 8 by 15 into CD into tan theta by 2 into square root of 2g into h raised to will be